So welcome back to the second video of the fourth chapter that is about the role of mechanical properties in engineering materials. So this video will focus on the tensile testing, and here is a demonstration. So by limiting the strength we have the maximum stress that if exceeded the material will break. So here are some questions that you need to keep in mind. For example, what is the tensile testing? What is it used for? How does it work? And the important part on a tensile tester. So we have the specimens pulling and pushing mechanism. We have the grips, the extensometer, and the fixtures. Also, we have some types of loading, the definition of elastic modulus, the yield strand, the tensile strand, and how to determine percent elongation and the true stress and strain, and finally the Poisson's ratio. So the tensile test is the usual laboratory technique for determining a number of important material properties like the tensile strength, the yield strength, the modulus of elasticity, the percentage of reduction in an area, and the percentage of the elongation. So here are some examples of tensile tester. Basically, the length of the reduced area section of the sample is measured by an extensometer, and it's a special device converting the length change to an electrical measurement. So for the tensile tester is a dog bone shaped sample, and basically samples are cylindrical rods with reduced diameter in the center, or flat plates with narrow section in the center. And this is another example. We have here the tensile tester and here the force deflection curve. This is another example. So basically the load is measured by the stress, the extension is the strain, and here is the stress strain curve or diagram. So also the elastic strain is recoverable and the plastic strain is not recoverable. The yield strength is the stress level at which the mechanical behavior changes from of elastic to plastic. And once the sample fractures, two measurements are made, the length of the final gauge area and the final diameter of the neck down portion of the sample. For the ductability, it's a measure of a material's ability to be stretched or drawn. So its general strength characteristics, and the modulus of elasticity is the measure of the rigidity or stiffness, and basically the elasticity is the delta stress over the delta strain, and ductility and toughness is the percent elongation and the percent area reduction. So we have here two examples, the comparison of true and engineering stress strain curves and the calculation of the strain hardening exponent from true stress strain data. And when a material is plastically deformed, interactions with dislocations in the material structure can cause the material to become stronger and harder. We have here the Poisson's ratio. And it's a demonstration. So some HSM international tests for mechanical properties here are in the table, and by the way, the tests are material specific. So now let's recapitulate the significance of stress strain data. So basically it's all about standard tests, properties that can be measured, measuring resilience, measuring toughness, measuring shear stress, and shear modulus.